Today, we're going to extend last week's VHS filter effect with tape wear and tracking artifacts. Let's go. So last week we created this cool post-process VHS filter that makes your project look like it was filmed on an old school camcorder with a VHS tape. So now we're going to add two additional effects to make this filter more convincing. First, we'll add some noise to make it look like the VHS tape is worn out. And then we'll add a tracking phase wave to make it look like the VCR's tracking is out of phase with the tape. All right, here's last week's shader that we created. We have our section over here that creates interlacing effect. And we have our section here in the middle that creates the chromatic aberration. And then finally here at the end, we transform to YIQ color space, which is the color space that VHS video uses. Then we do a little bit of color grading and transform back to RGB to output our final color. So today, like I said, we're going to be adding an effect that makes it look like the videotape is worn out. And then we're also going to be adding the tracking out of sync effect where there's kind of like a bar going up the screen of random horizontal noise. So the first thing that we're going to do is create that worn out effect. And in order to do that, we need to first bring in our texture coordinates. And we're just going to use the Y coordinate. And so I'm going to set my component mask to just the G. All right. And then the other thing that I need to do is append time. Now what I'm doing with these is I'm setting up some coordinates to pass into my random noise generator. I have a material function that I created in a previous video that's called hash23, and I'll link the video I'll link the video where this material function can be created. This is a really useful function. What it does is you pass in a vector2 value, and in this case I'm using the screen's vertical position as well as time. Those are my two values of my vector2. And then what I get in return is random colored noise in every pixel. So if we just take this, let's move this over closer to our root so that we can kind of preview this as we go along. If we just take this and plug it directly in, what you'll see is we get this random horizontal noise. And this is what we're going to use to rough up the output of our rendering. So now that we have that horizontal noise, we only actually need one channel of it for now. I'm going to use another channel in a minute, but we're going to just add a component mask, and I'm just going to take the red channel of that noise because for now I only need it to be monochromatic. Again, make sure you go back and follow this video where I create this hash because it can be used for all kinds of things. Okay, right now the range of our noise is from 0 to 1, but I want it to go from -0.5 to -0.5. And so to get it there, all I need to do is subtract 5 from my current range. And now I've got random noise that goes from -0.5 to 0.5. Now the next thing that I need to do is reduce the strength of this effect because it's really powerful right now. And so I'm just going to add a divide so that I can tone this down, because if I start using it the way it is now, it's just going to completely blow out my results. In fact, why don't we just go ahead and do that so I can show you what it looks like. So I'm going to bring in my texture coordinates again, and I'm going to add my result here to my texture coordinates. And then I'm going to use the texture coordinates to look up my scene texture. And I need to make sure that I set my scene texture not to scene color, but to post-process input 0, because when I'm creating a post-process material, post-process input 0 is the color from the scene that I'm sampling. All right, so I'm offsetting my scene texture using this noise, and if we pass this into our emissive color out, you can see that I'm distorting it so much that the scene is just completely unrecognizable. So I need to take the result that I've generated here and just tone it down quite a bit. And the way that I'm going to do this is I'm going to get the view size and add a component mask. And we're going to take the red channel of the component size, which is the width. So it's going to look at the width of the screen, and we're going to multiply the width times 0.25. And this is the amount that we're going to tone that effect down so that we get a little bit less distortion. So we're dividing this super strong effect by this value that we've just calculated to weaken it so that it will just distort just a little bit and we'll still be able to recognize the scene. All right, I don't know how well you can see this on the YouTube video, but what this has done is it's toned down that effect so that it's just really subtle, but what we're getting here is the look of a VHS tape, at least one component of it, a VHS tape being worn out. Okay, so there you go. You can see that I've created this effect where the tape is kind of worn out and it makes the edges a little bit fuzzy and strengthens the effect that we had before of those interlaced scan lines. Okay, so that is the first effect that we're going to work on for today. And the second part that we're going to do is that tracking out of phase feature. And what happens here is these old VCRs had this thing called tracking, where they had to sync up the phase of the frame with the speed that the VCR was running. And if things got out of phase, you'd see kind of this weird band of noise that would like slowly scroll up the screen. And so that's what we're going to create. So let's move our worn out VHS tape portion of the shader over to here. And we're eventually going to plug it in right here where we have our texture coordinates coming in. We're going to substitute this portion for the texture coordinates. Actually, let's go ahead and do that now. So I can plug, instead of just texture coordinates, I can plug in texture coordinates plus our VHS tape where. And then I can take a look at what we're getting with our final result with all of the effects connected together. So there's the result with everything connected. By the way that I'm showing how to do this is very modular. So here is the part where we have our interleave lines. Here's our worn out tape effect. This is our chromatic aberration. And then finally at the end, we have our YIQ color grading. These are all little individual modules. And if any point you want to make this effect cheaper, you can choose one or more of these things to leave out and just plug it together with the rest of them. It's kind of an interesting modular effect in that it's built with these different pieces. And of course, all of them are optional. So if you find something is a little too expensive, you're welcome to remove things to make it a little bit more simpler for yourself. Okay, so the next thing that we're going to work on, like I said, is that tracking phase effect. So in order to do this, the first thing that we need is a mask that is white in a stripe that goes up the screen. We're going to use that mask to add this effect. So I'm going to zoom in on my graph here, and we're going to add a time node, and I'm going to multiply time by 2 constants. So I'll hold down my 2 key and click, which gives me a constant vector 2. And I'm going to multiply time by 0.67 and 0.59. And this will give me a horizontal and vertical time value that are just slightly different from each other. And then once again, I'm going to grab my #23, and this is going to give me some random noise. And we're using a lot of random noise in here, and it helps to kind of break things up and give us some kind of more organic randomness to the effect. So once again, we're going to add our component mask, and we're just going to use the red channel of our random noise. And we're going to tone this down quite a bit. So we're going to multiply it by 0.15. Okay, so I'm just building up this noise bit here. Let's switch over to the part that actually generates the scrolling bar. So I'm going to add two constants, a 0.9 and a 0.96. And we're going to use a smooth step node with these values to create that scrolling bar effect. Okay, so I'm going to come down here where I've created that worn VHS look. And I'm going to grab the value coming out of here. We're going to add another component mask. And I'm just going to mask out the G of this. And this is the coordinate that we're going to use to generate so that we got this scrolling bar that's stretched horizontally but animated vertically. So this represents the vertical coordinates of our scene. And if I plug this in to our root, what you're going to see is this nice white to black bar. And that's what we need to begin with. But we actually need to control the size of this. And so I'm going to multiply it by 8 to kind of create this. Yeah, there we go. So this is the right size. Let's move these nodes back over to the spot where we were working. And now I'm going to add time. And to control the speed, I'm going to multiply time by a value of -2. And then we're going to subtract time from our texture coordinates here to give us that scrolling bar. And then I'm going to take what we've got here and pass it into a sine wave to create that repeating pattern. Now, one interesting thing about Unreal is that its sine wave, if you want it to act like a standard sine wave, you have to give it a period of 0.28. And that will create a sine that is that behaves the same way that a standard mathematical sine does. All right, so this is what is generating that scrolling bar that I'm going to use on the screen. Let's plug this in and see what kind of result I get. All right, cool. So this is going to represent that tracking out of phase effect. But I need to adjust it just a little bit. So this is where my smooth step node comes in. I'm going to plug the result of my sine into smooth step to sharpen this up. And we're just going to take the values between 0.9 and 0.96. Right now, there's a really smooth fall off here. And I want to get rid of that and kind of sharpen up these edges. So I'm going to go ahead and wire the result of smooth step into the emissive color. And now you can see, cool, I've got a much sharper looking bar. Okay, a minute ago, we spent some time and we built this noise effect. And you're probably going, wait, what about this stuff? So let's go ahead and incorporate this in. Right now, our mask here is scrolling really smoothly, and we want to add some jitter to this to simulate the way that an analog VHS tape would look. So I'm going to grab these nodes here, and we'll move them over. And then with these noise nodes, what we're going to do is we're going to add them to time. So we're multiplying time by -2 here. But before we do that, I'm going to take time here and I'm going to add it, or I'm going to add my noise into it. And now when we connect this up, what you're going to see is that bar is really jiggly now. And that's because of this random noisy time that I've added. So that gives us a mask that we can now use for our tracking out of phase effect. So the next thing that we need to do is incorporate scan lines into this effect as well. Right now it's just a solid bar and won't look as realistic as we need it to. And so in order to make some scan lines, well, we have some scan lines down here already, and we're using the red channel of the scan lines. I can just use the green channel of these if I add another component mask. So this is generating 3 different hash patterns, red, green, and blue. Here I'm just using the red one, but if I use my component mask set to G, now I can use the green mask as well. So let's bring this green mask up here. And if we plug this in, we can just take a look at what it looks like all by itself. So you can see it's just some rather chaotic lines there. And again, I'm going to adjust that by using a smooth step. So I'll plug this into my smooth step and we'll give it 2 values. I'm going to use a value of 0.3 and 0.7. So we're just kind of adjusting the range and the contrast of these lines. Now you can see I've got that range adjusted. So now that I have my bar mask and these lines, all I need to do is multiply them together and we'll end up with a nice jittery mask that's made out of these scan lines. And that is what we're going to use to kind of rough up our video. But before we do, we need to adjust the strength of this a little bit. Again, I'm going to be using the view size for that. So I'm going to add another view size node. And we're just going to take the width, which is the red. So I need a component mask. And we're going to mask out just the red of the width. And then I'm going to multiply this by 0.03. So the goal here is just to tone this mask down to a place where it's usable. So we'll add a divide node and divide by these values here. So here are my texture coordinates added to my VHS tape wear effect. And I'm just going to split these out into their U and V components by adding a component mask. So this one's going to be red. And this one's going to be green. And the reason that I'm doing this is I only want this to affect the red channel, or the U coordinate, not the V coordinate. So I'm going to add a subtract node here. And we're going to subtract this mask that we've created. So here is my V coordinate, and I subtract my mask from that. Then I need to put my U and my V coordinates back together. So I'm going to add an append. And now we have our final UVs. So we've subtracted out that noisy scanline mask. And now instead of using our UVs here, we can use our UVs that we've added or subtracted the scanline mask from. So let's go ahead and plug this in instead of that and see what we get as a result. Let's go back and plug in our final thing here. Yeah, cool. So now you can see that there's this pattern that's scrolling up the screen, kind of jiggling and warping the scene as it goes. So let's save this and switch back over to our scene to take a look at the result. There we go. So you can see that there's this area of the tape that is sort of out of phase with the way that it should be. And if you had an old VCR, there's this little knob dial on it that you can turn to get rid of this effect here. But here we are with an amazing looking pixel perfect pristine scene that we're trying to mess up and add all kinds of old-timey noise to. Pretty fun. All right, now there is one more thing that we can add to make this effect a little bit more convincing. I really like this one. This is really fun. Because we have converted our scene to YIQ, what we can do is take that effect and use it to influence our color grading. So with the YIQ color scheme, we have the 3 values. You can see this vector 3 here, 0.1, negative 0.1, 0. These values are affecting, the first channel represents the black and white, or the luminance. And then the second 2 channels represent the chrominance. So if we want our distorted scrolling tracking artifact here to discolor the scene we can actually use it to offset the chrominance values while we're in YIQ color space and then transfer back. And that will mean there's some discoloration in this area as it scrolls up the screen. That's pretty cool. In order to do that, we need to rotate our values. So I'm just going to add our rotator here. And then we need to split out our 3 channels here. So I'm going to add a component mask. This one's going to be the red channel, which is the luminance. And then the other 2 channels are the chrominance, and those are the ones that we want to rotate. So I'm going to plug these into the coordinate of our rotator. Now there's settings over here for the rotator, and I don't want to animate this rotation. I just want to offset it with my tracking artifact mask. So I'm going to set the center values to 0, 0, and I'm going to set my speed to 1 because this is a multiplier, and I just want it to multiply it by 1. And now I need to plug in my time value. And that value is going to come from right here. This is my mask that is creating my animated scrolling bar. And so I'm going to take this guy, and just to tone it down quite a bit, I'm going to multiply it by 0.3. So this is a scrolling bar that's scrolling up the screen. If we take a look at this really quick, you can see again, there's our scrolling bar. We're going to use that value to rotate the chrominance so that in areas where this is black, we'll get our regular hue values. But in areas where it's something that's not black, it's going to shift the color just a little bit. Okay, so we've multiplied it by 0.3, which is what's giving it, making it not go all the way to white. Then we're using it to rotate the hue or the chrominance. And now we're going to use an append vector node again to put back together the luminance and the chrominance. And then the last thing that we need to do is transform, use this transform block here to transform from YIQ color space back to RGB. Then we'll pass this out. And something went really odd here. I took a look and it turns out that I needed to include green and blue here. So if I check this box, yeah, there we go. Okay, you can see how right there in that stripe, our regular scene color is getting shifted toward green. And that's what these nodes here are doing. So I'm rotating the chrominance values using that mask that I generated that's scrolling up the screen. Pretty cool. Okay, let's take a quick overview of the whole effect. We've got our nodes here that are creating the worn out tape. And we've got our nodes here that are creating the scrolling out of phase tracking. And then we're adding those to our interlacing lines, our chromatic aberration, and our YIQ color space adjustments. So quite a few effects kind of building up here, but you can see the results are pretty neat. Let's go ahead and save it and switch over to our final scene. You can see that I've got this bar that's jittering and scrolling up the screen, and I've got the chromatic aberration and the interlacing effects. This interlacing may be a little bit too strong, and so I can switch back here and change these values to 2 and 5. This 5 value here represents the distance that the chromatic aberration is pulling itself apart. So if we save that and switch back to our scene, now it's a little bit more subtle, not quite so in your face. And this is looking pretty cool. Now there are a couple of more effects that I still want to add, but we're out of time today, so I'm going to go ahead and postpone those till next week, and we'll have a part 3 of the VHS effect next week. Well, let's go ahead and switch over to Unity, and I'll show you how to do this same thing there. All right, so here we are in Unity, and you can see that I've built the same shader here. Down at the bottom is the part of the shader that we created last week. On the left side, we have the screen interlacing, and that feeds into the chromatic aberration here in the middle. And then finally, we have the YIQ space color grade that we're doing at the end, where we adjust our color based on YIQ, which is the color space of the VHS tape format. Take a look at last week's video for all of the detail on how to create this part of the shader down here at the bottom. So here at the top, we've added the worn out tape effect and the out of phase tracking effect. So let's walk through how these are created. For the worn out tape effect, our goal is to create a bunch of random horizontal lines. For the randomness, we're using our #23 node, which is a node that we created in a previous video that I'll link in the description. This is a really valuable node to have. So our #23 node takes a set of UV coordinates and generates a randomly colored pixel for every pixel output. So to create random horizontal lines, what we're doing is we're taking the screen position's Y, or the V coordinate of the screen, and using that as our first input component. And our second input component is time. And what that means is that for every frame, we're generating a different random horizontal line. So you can see the result of our output hash looks like this. But we only need one channel of this randomness. Right now it's color, but we only need the effect in black and white. So I'm going to use a swizzle node to mask it out and just take the X component. And then to tone the effect down a bit, I'm going to divide things by the screen width multiplied by 0.25. And what this is going to give us is a toned down version of the effect. You can see it's not quite as high contrasty. That's because I'm taking this original effect here, which is, bright and high contrasty, and dividing it by our screen width multiplied by 0.25. Okay, then I take our screen position, which are the screen coordinates in U and V space, and I add this offset to it, which results in an effect that looks like this. It's pretty subtle, but if I zoom in here, you can see that my original screen space coordinates are kind of noised up with these random horizontal lines. So that's how we create our worn out VHS tape effect. Now for our other effect, we're going to be creating an out of phase tracking effect. And basically what this is it's a large horizontal bar that's scrolling up and down the screen. So in order to create this bar, first of all, I start out with the UV coordinates, the noisy UV coordinates that I've generated here in my worn out tape effect. And I just take the Y coordinate here. Then I multiply that coordinate by 8 to control the size and shape of the scrolling bar. And then in order to make the bar scroll, I subtract time by it. And I've taken this time node here and multiplied it by 2. We're going to skip this add for now, and I'm going to come back to it in a minute. So for now, I'm just going to wire my time node directly into this multiply by 2. And then we're going to subtract the result of that from our UV coordinate. And what this is going to give us, after we pass it into our sine node here, is this scrolling bar. I'm just going to open my graph inspector and set the preview of this node to 2D so it's a little bit easier to see what's happening here. So we have this gradient here that's scrolling along nicely, but our gradient is a little bit too smooth, and we want a bar that's a little bit harder edged. And so the way that I achieve that is I pass my sine wave here into a smooth step, where I'm saying in the smooth step here, anything below a value of 0.9 is going to be black, and anything above a value of 0.96 is going to be white. And so the result of that smooth step is a nice sharp bar here. Now, there are two problems that I want to fix with this bar. Number one is its movement is a little bit too smooth and regular. And number two, it's a little bit too perfect of a bar shape. and I want to break it up with some scan lines. So first, let's make the movement of this bar a little bit more jittery. So in order to do that, I'm going to come over here and use my hash again. But instead of passing in UV coordinates to my hash, I'm going to pass in time, which will give us random offsets per frame. So here I'm taking time and multiplying it by a vector 2 so that in my the two channels that I'm passing into my hash23 node, I'm going to get different speeds of time. One is going to be multiplied by 0.67 and the other by 0.57. So I take that value, multiply it by time, and pass it into my hash. And what that gives me is every frame I get a different random offset value. But I only actually need one of those offset values, which is why I'm using this swizzle node here to isolate out just the X channel. And then I tone that value down by multiplying it by 0.15. So every frame, I'm getting a different offset value, and I make that offset a little bit smaller by multiplying by 0.15, and then I add that to my time. So instead of moving continuously, every frame my time is going to be slightly offset by this noise value that I've created here. Then I'm going to add that value, but then I'm going to wire that value into my multiply here. And the result now you can see is this bar that is jittering, because instead of increasing smoothly, my time is now offset by a small amount, which gives me this jitteriness. Okay, the next thing that I need to do is add some scan lines to this movement, to this bar here. So in order to do that, I'm going to come back to my worn out tape mask effect. And here, I'm generating random horizontal lines with my hash23. But I'm only using the first set of lines here because I'm masking them out with my X. And I actually have two more sets that I can use here in my hash23. So you can see I've got this wire here that's coming out, and I'm using this swizzle Y so that I can mask out the second set of random coordinates or random horizontal lines. So here's that second set of random horizontal lines that are animated. And you can see here that I've got another smooth step. And what this is doing is increasing the contrast of those lines. So I take a value of 0.3 and a 0.7. And what that gives me is horizontal lines that have higher contrast. So then I take those lines and I multiply them together with my scrolling bar here to give me a final result that looks like this. So I've got this scrolling bar that's really noised up, it's jittering, and it's got these scan lines going through it. But this is a pretty harsh effect, and so I need to tone it down a little bit so that I can use it for my final result. So I'm going to take that effect and divide it by my screen width multiplied by 0.03. And so my final result you can see here, instead of this high contrasty white bar, now I have a little bit lower contrast here because I've multiplied it by this value. And so I can use this to not warp my screen coordinates quite as much. So if I control this value here, if I reduce it, it'll give me less of the out of phase tracking effect. And if I increase it, it'll increase the strength of that effect. So there's my final result for my out of phase tracking effect. And now I just need to combine it with my worn out tape effect here. So here's my screen position. I'm adding my worn out tape effect to it. And then over here, I split it into its two individual U and V channels. And for the first channel, I subtract out that out of phase UV tracking effect. So you can see that I'm only affecting the first channel of my screen UV coordinates with that out of phase tracking. And then I combine my UVs back together for a final set of UV coordinates here. And this is what I'm using to look up my screen effect. Great, so then I pass that into my chromatic aberration. And just like we did last week, we're sampling our screen twice with those screen space UV coordinates that I've noised all up with my worn out tape effect and my out of phase tracking effect. Now, for one final touch to this, I'm taking my results here at the end and transforming them into the YIQ color space. And in YIQ color space, the first component of the color represents the luminance, and the second component represents the chrominance. So if I want my out of phase tracking effect to shift the color a little bit, to shift the hue, what I can do is take the luminance here, which is the first component, and pass it directly through. But I'm going to separate out the second two components, the Y and the Z, which represents the chrominance, and I'm going to rotate that hue based on that scrolling mask. So if I zoom out here and come up here, you can see that here's my smooth step node that's generating my scrolling mask. And I'm going to take this value down here. First of all, I'm going to multiply it by 0.3 just to tone it down a bit, just so it's not quite so extreme. And then I'm going to rotate my chrominance by that amount that's coming in from my scrolling bar. And what that does is it's going to shift the hue of these values wherever my bar is something other than black. And also, one other thing I want to point out is just that you need to set the center here to a value of 0, 0. Okay, then I take the output of that, split up those, and pass them back in as the two values of the chrominance. So here I'm combining my luminance here with my chrominance here. And then finally, I'm using this matrix transform here to transform back to RGB space. And this is something that we covered in last week's video. Then I pass out my final result. So there is the VHS shader as it stands now. You can see that I've got my interlacing effect, my chromatic aberration, my VHS YIQ color space grade. Then I've got my worn out tape effect and my tracking, my out of phase tracking effect here. All right, well, let's save this and take a look at what the final effect looks like. All right, so here's our scene, and you can see that our VHS effect is really coming together. We have this effect that's scrolling up the screen here, that's changing the offset of the scan lines and also the hue of the color space. And we've got a little bit of chromatic aberration and some worn out tape effects all mixed in together. All right, next week we're going to use one more video to talk about these VHS effects, and we're just going to add a few little touches to add the cherry on top. We're going to have episode 3 of our VHS effect, and then we'll finish it out. Thanks for watching today, everybody. I hope you've learned some things and that you can now apply this cool VHS filter effect to your scenes if you want to make it something look like it's been filmed with a retro camcorder on VHS tape. All right, have a great week, and we'll see you next time, everybody.